Session 7 of 2 weeks Atal FTP on research avenues in biometrics using low-cost devices. And session 7 to 14 is in the offline mode. And today we have the first session in the offline mode by Dr. B.A. Shekhar sir. Hope you all were there in the inaugural function to know the introduction about Dr. B.A. Shekhar sir. And more you'll get to know through his talk. So we welcome sir for delivering the first session of the offline mode. As you see, the deep learning based models for multimodal biometrics. Actually, when we started our research under his guidance, sir had dreamt of designing a multimodal model or a multimodal environment-based biometric system, and there is when I chose to work on handwritten signature. Professor Sharmila Madam, who is the speaker in the afternoon, chose to work on face and so on. So under his guidance, almost all the basic traits of biometrics is being covered in his laboratory. So now I welcome Dr. B.A. Shekhar sir to deliver his talk. Sir, for the assistance.
Thank you, Dr. Bharti, on this occasion to share my experience with all of you on this development aspects, particularly concerning multimodal biometrics. Although my talk is little generic, may not be more focused on multimodality, which probably the next speaker would speak about the same. I'm trying to give you here the very basic fundamentals that you need to know in order to carry out a research work in the field of biometrics and also in other areas. Not necessarily you can restrict yourselves to the biometrics. Wherever I say computer vision, you can think of deploying deep learning based models. So I just would like to know how many of you already studied computer vision, biometric or multimodality, familiarity, except the organizers and the just basics. Okay. I may cover the basics once again, maybe a repetition for you. So, but the perception is going to be different as you know very well. The way you perceive the information will be different from the way some other author has perceived. That's why you know there are different developments in the research area. One would see, for example, if I can the image data, as a mathematician they can say it is a matrix. As in the morning session our Guru Professor Kumar pointed out. As a signal processing person, you would say that it is a two-dimensional light intensity function. So means you can define in different ways and our algorithms based on the domain expertise. Suppose if I am using mathematics, probably I look for designing the algorithms, exploring the domain knowledge of matrices that I am having. So similarly here also, so deep learning is more or less basic mathematics, statistics. So therefore, and little bit of image processing also, and definitely we can think of employing the models that are so far available in the domain of computer vision, artificial intelligence, machine learning, deep learning. These are the technical terms that you are finding out in the recent literature. And we are trying to throw a light on those issues. What is basically required for a researcher? What they need to know. So rather than giving you the mathematical details, because definitely in a session of an hour or so, I am sure if you focus on a particular concept, definitely it is possible to cover the mathematics behind that. Simple example, maybe say for example, SGD, stochastic gradient descent data. So, which is very, very interesting, of course. So, there are many such what are called as the optimization algorithms also available. So, which you need to explore. We are trying to provide you here the basic anatomy of the deep learning model, which you can continue your studies further to enhance your particular area, that is in the field of computer vision in general, and in particular multimodal biometrics. Probably taking some inside details from this workshop. So I'm sure you may be motivated to take up the work on biometrics. How many have identified the research problem, or those already completed research? Anybody completed already research? Here, I mean, other than the internal faculty, external, those who come from the, okay, it's good. So I'm sure it may be useful attending to this workshop, knowing the what current works that are being carried out in this area, such that you can entrust the works to your students. Because you know very well that having attending any kind of workshops, be it technically or any conference or for that matter, so it will reduce your reading time. So getting first-hand information, what is covered in 1 hour would be your 20 to 25 hours of reading. So that is the benefit of attending the workshop in that context. I'm trying to give you very basic fundamentals and explore the various applications, and then little bit of internal details, such that, and the outline of what is the idea of employing such what is called as the, or having such a mathematical model. Those details will be provided in this talk for about 1 hour or so. Okay, and definitely you are welcome to seek the clarifications at any point of time, or at the end, so that coverage should be made whatever that I have planned in this 1.5 hour session. And I know it is the first offline session for all of you. So you attended in an online mode, and online mode has the liberty, isn't it? So liberty in the sense that you can freely walk around, can listen, or may not be, sometimes that may be the case. And it is all the interest, because definitely it is your interest and also curiosity to know about the subject, so that you can enjoy, even for a teaching for that matter, doing research for that matter. Only when you understand the basics, you feel proud about yourselves. Being a teacher, I'm sure many of you are teachers here. You can really enjoy any session while teaching to your students' community when you know the inside details. That is most important. And probably even for research, it is most important. Suppose if you want to add something to the existing works, so I should know what is so far already happening. That's what in fact literature survey will tell you. So basically deals with what are the state of the art, we say generally SOTA, algorithms that are available on a particular area. Because you cannot take up the work which is already done. So that is where your readings are most important, and readings on the standard journals. Probably those issues might have been discussed by Professor Murali and others on research aspects, skill set that you need to have. What is the current technology? What is the current development? Because you know, any journal for that matter, if I consider, so generally you should refer to a standard Scopus indexed Web of Science SCI journals, because that gives you a strength. So that makes you to read again and again a particular research article. Maybe that is the idea, is it is also insisted to have 2 journals that you need to study, but published in a reputed publisher. Okay, maybe IEEE or a Springer or elsewhere. And I insist at the end, probably not only looking at those 2 journals, I will also give you 2 more copies. Okay, apart from that, because that is the one paper which is referred, cited more than 1,20,000 times. Can you just imagine? That is in the area of deep learning. Okay, what we call it as an AlexNet. Probably some of you may already aware of it. So that is the as such today's number of citations. That particular author, Chendex, is increased, and his citation count exceeds the citation count of many other well-known researchers in the world. I mean, it takes birth in many ways from 2012 onwards, but we will look at the components of such what are called as architectures. And as a beginner, maybe some of you are beginner here, just implement, develop from the scratch, okay, all those what are called as the modules or the algorithms. Don't refer to the Keras library or PyTorch, where in which there are standard APIs that are available. Don't use the standard APIs, try to build on your own. And later on, you can just play around. That's what I insist, because that gives you more strength. So then later on you can look at how deep learning works, all those things at a higher level. As I told you already, deep learning is basically a kind of abstraction, because many of you are from the domain of computer science. So we can enjoy our discussion, exploring the knowledge that we already gained. I would say, for example, image, let's say if I consider, it's a two-dimensional data structure, array for matrices. And you can define various functions on that image data. And I call it as a class having the image data type and performing various operations on it. The operations may be a convolution, the operations may be addition, operations may be subtraction, or operations may be extracting a desired block, an interesting block from the image data. Splitting, whatnot, you can perform different operations on the same. I mean, we can link to the areas that we are already familiar, in fact, with. And how this particular simple concept has been explored for solving very complex applications. That we will see, of course, in the course of discussions, going through some of the videos. So as a matter of fact, because just to take you to the line of discussions and from the point of view of continuation, I'm sure you are all familiar with the definitions and the terminologies. Okay, so these are the buzzwords that you used to now learn in the industry, and it is the artificial intelligence that is gaining momentum, and job avenues are more, and many engineering colleges started AML course, data science course, right? And then intake. And equally, we have many opportunities that are created. It's all because of the enhancement on the other side in the hardware industries also. Although, as Professor Hemant Kumar pointed out, that this artificial intelligence exists almost 70-75 years back. It gains momentum in these years, particularly from 2012 onwards. So after introducing what is called as the deep learning, okay, and again it is a area in the neural networks. The artificial neural networks are very well known to the field of research community. So those who are working in the field of computer science, particularly those who are working in the field of pattern recognition. So some are in fact familiar with the notion of this what are called as neural networks. And in between A and DL is the machine learning. It basically contains a set of what are called as the algorithms that are used to realize the artificial intelligence. So, and one definition that I used to appreciate when you refer to the AI textbook, which textbook you used to refer to artificial intelligence for teaching or for reading? If you happen to read AI, no problem, otherwise doesn't matter. Okay. It's like a Bible, we say. For example, C++ if I consider. C++ if I consider. Which textbook you are used to read? Balgus. Okay. Who was the inventor of C++? Huh? Yeah, straw. And he has written a textbook, right? It's a wonderful. I don't know how many of you have read, but please look into that. Similarly, the C language, Cunning and Ritchie. It's hardly 100 to 120 pages, but gives you an excellent coverage on inside details of the C language. And the kind of problems, assignments, what is given are interesting, because rather than finding the sum of numbers, things like that, he has given excellent assignments that you need to solve, because that gives you a flavor of any programming language further. Okay. Anyway, why I come to that point is to read the textbook, read the journal, which are of some standard. That's what I just wanted to insist here. So when I say it is a standard, when I say a particular article is very standard, it is definitely receives a lot of citations. So that's why I told you in the beginning, so having 120 citations, it means you know the power of that particular article. It is not something new, it is already known to the research community, but the design in such a way that it is useful and more capable of identifying the objects. So it's basically image recognition competition, and they developed a model. So I'm sure as a beginner, we cannot think of implementing or realizing such systems. You know the complexity. Anyway, if not known to you also, we'll take that particular slide from the author so that you will come to know how complex the system is when I'm trying to design the LXNet. And using LXNet, you can think of designing additional models. So what generally called as pre-trained model in the context of deep learning. We can use the features or the weights which are already trained, and subsequently I can make it suitable or tailoring it to my particular problem. The problem may be for face recognition, problem may be for fingerprint identification, palm print, and so on. So whatever if I say it is a ban. In the sense, if I say it is so artificial intelligence, I mean, as you can see here, particularly it gains momentum from 2010 onwards, as you can see from this slide. So means to say there is something reason behind that. As you know, computational power are equally more required, and it is all because of again the kind of strategy that is being considered in the area of, say, deep learning rather than the machine learning. Although when I say AI is meant for making with minds, that's what we are trying to say, simulate the human minds. With machine learning it is possible, but human intervention is required. But as far as deep learning is considered, little extent, to some extent, human intervention is not required. So that is a fundamental difference. Although it is one of the strategy or a technique under machine learning, it is quite different from say called as machine learning in this context. So the only significant difference you can find out over here. So given, say for example, certain object, instance of an image, so I do the handcrafted features. That's what is done all through the days. So all through up to 2010, 12, people tend to explore, even after 12 also, and in some situations we are supposed to go for the handcrafted features also. It's sometimes also called as the feature engineering and feature extraction. We may say different terms. Characteristics, suppose if you say you are from the domain of database management system, I would say an attributes. Characteristics, what should be the nature, what are the distinct characteristics that I should specify. It's again, it is from the numerical data that I am supposed to extract those characteristics. And there are so many algorithms so far available when it comes to what are called as the handcrafted feature. And some of you may already familiar with the kind of handcrafted features. If not, you are going to learn in these 6 days. Maybe online workshops also has given what are the different feature extractions types that are available, and not all class of problem are suitable for employing the deep learning algorithms. We will come to that at a later stage. In what scenario we can think of employing the DL models, in what scenario handcrafted features are good, or shall I go for a combination of both? Again, it is an interesting question, and people addressing that. I mean, use the power of your vision, extract the features, and combine with the deep learning framework and come out with a solution to the problem. That's also possible, which we say what is called as integration of different ways. However, my human intervention will be required in such cases. On the other hand, when you say here deep learning, it is, I call it as an end-to-end learning. And the learning goes at various levels, as you can see here. So those who are may studied, already explored deep learning models, they know that there are several layers, what are called as the hidden layers, that are considered in deep learning architecture. What are the reasons for this? The reasons are that they will use to extract the low-level features, mid-level features, and high-level features. That's why I told you it is a deep learning is a kind of abstraction. So abstracting a model at various levels. You are going to slice you are going to visualize a particular system at various levels. It is as good as your studies. So maybe for example, 8th or 10th standard student, so may not know the internal structure of human brain or the eye structure. So overall, or even computer system for that. They would say simply, nowadays 6th, 5th standard students, they would say computer is nothing but a keyboard, an input device, display unit, and a processing unit. Nothing more than that, and the functionality. And later on, you are going to look at the internal details of designing a CPU, processing unit. And again, you go little lower, how to design arithmetic logic registers and things like that. It goes at various levels, which we call it as an abstraction in the context of what is called as the object-oriented modeling. So deep learning is a kind of exploring the object details at various levels, and for that purpose we are having a mathematics behind that. Okay, what is the mathematics we will see in the course of our discussion at the end, and I complete you will come to know. I mean, we are supposed to, when I take the mathematics, where exactly, what is it interpretation? It is most important. So if you could able to interpret, I'm sure it helps you why it is required and all those things. Okay. So ultimately, when I say it is a deep learning model, it doesn't require what are called as the feature engineering. That is the only difference that you can see. And unclassified, you could say the design. And as I told you, if I say here it is a neural network, so it is not only today's this one area. It's in 300 BC. It starts from 300 BC, as you can see there. And it's more than, particularly you can see the contribution from different researchers. Starts with, how many of you read artificial neural networks? If not, don't worry. You will see it as a black box. Okay, nothing to worry on this stage. And at the end of this workshop, you should design a neural network model for some applications. So it is not possible in a 1 week workshop to explore or study or invent something new. But you should know how to build a simple system on a small data set. Because basically when you consider the deep learning, I'm sure it is able to solve the complex problems where the amount of data is very, very huge. Again, there is a question, what do you mean by and how much is the size of huge? I mean, it varies with the different class of applications that we are having. So start with basic neuron, McLaren-Fitts model, and there are problems with that. Subsequently go to a perceptron, then it goes to multi-layer perceptron because of the limitations of the single perceptron. So people proved single layer is not good enough just to design the, any idea? Exclusive, I request to keep your mobile in a silent mode because it is a processor switchover will take place. Please. So, when we say a perceptron, it is unable to solve a simple problem, what is called as simulation of the exclusive orbit, which is not possible. Therefore, people thought going for a multi-layer perceptron. So, when I say it is a multi-layer perceptron, at some point of time, they restrict it to only one hidden layer. Have the input data, have the intermediate, what is called a hidden layer, and subsequently an output layer, which is also used for the purpose of identifying the object in the investigation. So that people thought that it is able to solve all kinds of problems. A lot of investments were made in the by the industries, thinking that artificial intelligence is able to solve all sort of problems, but it was a myth. Maybe in 1996, people withdraw their funds investing onto AI companies. Fortunately, later stage, there is a story behind that. IBM Deep Blue defeated Gary Kasparov, and that is where again people thought having a dedicated hardware devices, high-end computation, it is too possible to realize the system. And for different class of problems have been developed once that is successfully deployed onto kind of what is called as a gaming. And nowadays you have seen lot many applications in the field of this artificial intelligence, machine learning. There are many, 100 number of opportunities and also the applications, industries, for various problems. This is just a list that we are, it may be healthcare or it may be education or it may be a biometric, okay, attendance management. So many automated, what is called as machine translation. When you are browsing the net, automatically text comes. How the machine knows that you are typing this or predicting the text prediction. So it may be an inside some app is running such that it gives you a clue. Similarly, when you are browsing through your mobile device or so, it will always list you the searches which are related to you. I hope you experience it. Say for example, I am interested in a football because that is the current going on game, as you know very well, right? You keep on searching and automatically the Google search engine in a smartphone, they give you what is the recent what are called as the games and the corresponding score, etc. that you find. Some may be interested in purchasing clothes in online store. Then as and when a new product comes from different agencies, automatically it gets reflected when you are browsing the net. So all these things again is the contribution from the field of AI. Okay. So in a sense, so it has potentially many applications. We are going to see all those, of course, and this is just a video to give you a glimpse of that. I would say, okay. The operators, when I say it's a deep learning model, okay. So similarly, as you can see here, optimizers, loss functions, initializers, and regularizers, okay. And please look at least one or two, if not all. It is not possible, I will tell you, because you can experience it when you start working on that. So at least one of the optimizer, one of the operator. Don't take a very simple operator. For example, pooling. Max pooling is very simple. So please don't take that. Take little bit more complex. Okay. Optimizer also, and similarly the loss functions, and similarly the initializers. So initializers details in fact are also available when you look at your. So when you refer to the Keras, which is an API, contains a lot of library functions. On top of this, you can find different initializers as you can see. So means to say that when you go for random normal, okay, and random uniform, so truncate normal and so on. I will tell you the role of these initializers. Initializers play a significant role also. And that is where the birth of transfer learning approach comes in. I am going to have the initializers initialized the pre-trained models. ImageNet, the AlexNet, what we have considered, is pre-trained on the ImageNet and subsequently deploy to a face recognition, fingerprint, palm print, and so on and so forth. That's what people are exploring. Okay. But if at all you want to have a breakthrough article, then probably you need to look at how to have a different loss functions. Maybe an interesting research. It is a matter of identifying different loss function. It's a matter of identifying a different optimizers. It is a matter of going with what are called as various convolutions or as a max pooling. So, and you cannot randomly or blindly fix such what are called as the operators or the optimizers. You should have the intuition behind that. Having such optimizers, what is the use? What basically it captures? That is most important. So philosophically, what does it give me when I do such processing? Most important. That's what I'm supposed to know about. Okay. So in the sense, when I go again further over here, so deep learning, as you can see, layers are there, convolution layers, max pooling is there. Similarly, activation functions. There are so many activation functions. Even changing the activation function will have a different results. And one such example is the ReLU activation function that is considered in the AlexNet. Computational complexity drastically reduced. So in the case of ReLU activation function, rather than considering the sigmoid function. You know the function of the sigmoid, where the values lies between -1 to 1, and here it is 0 and maximum that value is considered. So which drastically reduces the computational complexity. I will show you that slide at a later stage. And again, this is thought, is invention. And if you are able to, say for example, design such large functions, okay, which is suitable to any kind of problem that are already available, not necessarily to invent a new problem. So even a face recognition problem, if you are able to come out with such different optimizers. Optimizers are the contribution generally from the mathematicians. Okay, different optimizers already available. So can I suppose in mathematics, domain of mathematics, somebody has invented a new optimizer. So immediately can deploy in your domain and can integrate. That's the advantage for us, particularly those who are working in the field of image processing. We can borrow the concepts from mathematics. We can borrow the concepts from physics, signal processing, and all those. So we know that signal processing people give theory on wavelet theory, say for example, discrete cosine transformation, Fourier transform, and so on and so forth. And we are using for signal processing, considering that this image is a two-dimensional signal, speech is a one-dimensional signal, which varies over a time, like this. So regularizers, of course, L1, L2 norm, all those things could be considered. Dropouts. Adding a dropout is again a contribution. Just eliminating some unwanted data. So rather than processing entire data, eliminate some unwanted. We call it as a dropouts. So simple term that has been introduced. And it drastically reduces the computational time in the network. So again, getting deep into what are called as the layers over here, could be densely connected, or it could be recurrent, as you can see here, or it could pull it. So usually have a state and encoded as a weights, and of course when combined, form a network or a model. Form a network or a model in the sense that, as I told you, it could be an AlexNet, VGG, and so on and so forth. Just a simple, what is called as set of these functions, set of these layers. These layers are used judiciously, okay? And why we need to use them judiciously? Let me just illustrate it, okay? The copy of the slides will be given, PDF, therefore you can just have a discussion. You won't need to write. Okay. So what do you mean by saying a convolutional kernel? All of you are, I think, familiar with image processing. So you know what is the meaning of a convolution operation. And no author has given you inside details of the kernel functions. That I have noticed. I read many textbooks. So gone through different literature. They don't give the internal details of, let's say I use 36 filters. Which are those 36 filters, it is not revealed. But you need to do searching, where exactly those filters and what filters I am supposed to use, those kind of things. So some such filters are these. You know the nature of these filters, as you know very well. If at all you are from the field of image processing, edge extraction, the corresponding filters are there. What is the task that is being done in this case? What is this case? What is in this case? What is in this case? Any idea? The name itself says, in fact, when you studied image processing or not?
Yes.
Blurring and Gaussian blurring, I said. What do you mean by saying Gaussian blurring? What do you understood by blurring? And why do you need to blur the image?
Remove noise.
Yeah, basically people say it is to eliminate unwanted noise, right? Some spike signal may be there in the image data due to noise. Then automatically I want to suppress that information. Then it's as good as looking at blurring. I mean, you take for example text or so, right? And you observe from the certain distance, 36 centimeter would be the common, as you know very well. Then keep bring the same to your eyes near. Can you read it? It's not possible. That's a kind of what is called blur. So what do you mean by that? You are increasing sigma or decreasing sigma? As far as Gaussian kernel is concerned, RBF kernel that you would say. Sigma. Having lower the sigma, what is going to happen? Having higher the sigma, what is going to happen? Okay, just think and see varying sigma, what is the effect? Or else you take a simple average filter. You, let's say for example, you smooth the image, image smoothing probably you know in pre-processing. You smooth the image with various filters of different size, with filters of different size. Let's say I take 3 by 3. See what is its effect on the image. Take 5 by 5. See what is its effect on that. If you increase the size of the filter, more the amount of blurring you can find. I mean it is as good as rubbing, that's what. In simple terms that I would say. So it is rubbing, if you put so much hard rubbing, then everything gets vanished, gets more smoothened. That is, size of the kernel is very large. And people have played with that. When you are designing a neural network deep learning model, they played with various convolution kernels. They take 3 by 3, they take 5 by 5, take 11 by 11, 26 by 20, and so on. So generally it is odd size filters. It's all because of the reason that the pixel and the processing could be placed middle one. So otherwise there is no reason. You know that even it is not a mandatory even otherwise. Okay. So they say it is a 96 filters they employ on the image data to convert, to perform the convolution operation. And even today I am not able to get all those 96 filters. But we have a function available in Keras to perform the filter operation, right? So, but I want you to design convolution kernel on a given image data. Take different kernels and see what is going to happen. And take a color image generally in a different place you can work on and see what is the result. Okay. This is just a GIF file illustrating what will happen on the image data. And as you can see here, your 5 by 5 image is resized to, of course, 3 by 3, right? Doing a convolution operation. And it is possible to have the same size. What is the kind of operation that you need to do?
Padding.
Padding you are supposed to have. And sometimes they are also called as, that is a term that is being used in the literature, such that I can keep the same size of the data. Suppose you would like to reduce the size of the image to be processed, simply do the conversion to a file so that you get the results. Automatically it gets. That's what the idea behind that. So in a way, when I say this is, playing a very significant role in the design of deep learning algorithms. So please implement at least 4 to 6 filters and see the results that you have. And it should be from the scratch. Don't use the existing APIs. Read the image data and don't use a filter 2D operation. Don't use that. And it supports you various functions that are available. Gaussian and so on, orange, etc. Those things are available. Try to build things. It is the simplest task. It's just moving or running the kernel over the image. How to run the kernel over the image. That's all it is. It is simply an order of n square operations, if I say it is in simple matters. Okay. Multiplying the weights and then replacing them. It looks simple, but when you try to implement it, it will take one day. You just experience. Okay. And I want you to experience. Then once you master in that, you tend generally not to forget, so that you can just understand when reading any paper, what do you mean by saying a convolution operation. That's all I want you to say. And having the various size, what is its effect? So having the varied size of the kernel will have an effect on the kind of what are called as the data that you are going to interpret. So lesser the kernel size, smaller the features, higher the kernel size, bigger pictorial information that you are going to capture. So global, then you go to many of the algorithms that you can see. So initially they have a bigger size kernel, and later on they downsample, and then do the, again, reduce the size of the filter and then execute again the convolution operation. And trying to extract the or visualize or obtain the characteristic of the image, running the kernel through different what are called as the size of filters. So to say that I am having the input, and then you will be having what are called as this set of what are called as the layers which transform the data to another form. That's all. As you can see here in the previous slide, it transforms this data, okay, this image into this image. What is the benefit that you would get? Pictorially, I may not able to say anything over here, right? Intuition. What is the intuition behind performing the kernel operation over here, convolution operation over here? That you need to know. So if you could get that, I think then only you can understand why I need to perform the convolution operations. Of course, the next task is the optimizers. Okay. These are another component. I will go further probably at the later stage about the convolution, little bit details. Okay. Now coming to the optimizers. What do you mean by saying an optimizer? It is a simple what is called as estimating the minima or the maximum of a function. And it is a POC, I think, concept. How do I estimate the local maxima or the local minima? Or in degree, you might have studied. There are various algorithms that are available to estimate the local maxima or the local minima, which is can be through derivation. Okay, differentiation operation is one such mechanism. And in fact, when you look at here, I told you the initializers. Okay, at the beginning, what are the different set of initializers that are available? So when I say initialize, if you initialize at the right place, then it gets converged to a local minimum. Let's say if I initialize somewhere else here, it may not converge. So in such cases, what is the solution for this? And choosing the right position is a complex process. Nobody knows what exactly and what way that I should initialize the data. And that is the reason people tend to go for what is called as transfer learning approach, where the ImageNet trained models like Alex, VGG and so on gives you the weights which are initialized, and subsequently those weights are going to be used to learn or to make the deep learning model which works for a particular problem of your choice. That is the advantage. And there are so many algorithms that are available. So I want you to implement, this one, stochastic gradient descent aside. Please Any one algorithm is good enough for me. Bharati probably can given as an assignment also, right?
Sir, two articles is given.
Sorry?
2 articles is given in which.
Apart from that, they'll let them also do this job, okay? Because you come here for learning, do that learning and let it be better learning, okay? So that your brain is trained well, you can take up the research further and also guide your students. So that's what when I say it is an optimizer. And similarly, when I say your the other some more components. So max pooling. So max pooling, you know very well. Given an image data, just decompose, take the block of intended size and then take it the maximum value. Very simple means of implementation. But there is one beautiful video, in fact, to illustrate this max pooling concept. I'll just run this. Of course, it is a two-dimensional representation. As you can see here, trying to estimate the local minima also. So, which you can see this right. I initialize the weight somewhere else here, and then it gets converged. And there is an algorithm for this. How exactly the algorithm converges? Just try to simulate this and display a graph also. Very interesting. Okay, try to give a graph, and for a graph you can use a matrix plot library. I don't want you to build again from the scratch the graphics part. So use a matrix plot library and see whether how your what is called as the initializers, which may be of course a circle over here, comes down to this stage with at each and every stage it converges to the local mean. That's what you need to do. Okay, simple mathematics is there behind that. I told you already in the beginning, first session, let me not put you mathematics but give you the philosophical view, what is its interpretation, so that you can go through in detail of every stage. Okay. Similarly, this would be another example in three-dimensional representation. It is available in MATLAB, in fact. People, so, I mean, instead of having a two-dimensional plot, you can also have a 3D plot, which says that when I keep an initializer somewhere at some point, automatically it goes down to, as you can see there. Okay. So this is just a different pictures. And you know, as you can see from that, it is implemented. So, question. Somebody was given a contribution. On the other hand, last functions. As you can see here, the only thing the network cares about, there might also be the other metrics that you are supposed to care about. Network will look for only the different loss functions that are common standard loss function. It's simple one, mean squared error. It's not that much difficult. Okay, you know what is MSE and how to estimate MSE. Okay. Similarly, cross entropy or categorically for more than. And the details, in fact, I've just taken one search. There are so many blogs that are available, which will give you the details of several loss functions that are available in the literature. So many loss functions are available. Please make a study. See, automatically this gets retrieved because I keep on searching what is available in Python for addition. No coding experience. When you go to a particular website, something gets retrieved immediately. As you can see here, there are so many loss functions. Try to implement at least few, which are very useful for you to understand. Just rather than giving it as a parameter, okay, please understand what it is. all pieces of function that you are supposed to do so that you can understand in full deep learning models. We are trying to know about the functions of each and every building block, that's all. Okay. See, as you can see here, it's how well a method of your algorithm notes models your data. That's what the task of the last function. And we have listed here some regression loss function, binary classification function, multi-class classification. So these are quite simple, regression loss function, and I want you to look at multi-class classification loss. Please implement any one of these, okay? Or at least cross-enter. It's interesting, in class. People tend to use these as a part, as a parameter to different deep learning models. Okay. And once you know about the same, probably the next thing is the framework. I mean the set of, this is where we enjoy our learning. Without knowing internal details, we try to use, not fair for a researcher. Please look into the details that are available. So, particularly, lot of functions that are available in these packages. Python comes with so many functions that we are unable to use even now, and it is like a Linux environment. It contains, I don't know whether you explored or not, just for the sake of my completeness I think. CC, the compiler material, serial class. Have you done compilation of program? How many of you explored the different parameters that are available in CC compilation? Question explore ಮಾಡಿದ್ದೀರಾ? There are more than 80 to 90 parameters that are available in compiler option. You can obtain an optimized code, you can obtain a binary code, you can obtain an assembly code if you are interested in what is called as the theory of compiler design, like lexical analysis, then syntax analysis, okay, then intermediate representation. So you can obtain a machine code, you can obtain an intermediate code, executable code, okay. You can stop the compilation process at various stages. Why I am telling those? I mean to say it provides you a number of features. Generally we don't explore all those. What is required for us, we take it and try to forget. That should not be. Let's say for example you are going to use the API. Please look at the complete detail of that particular API and the syntax and the semantics first. And it is available. They have given you a beautiful what is called as a notebook which contains all such details. Let's say for example I say filter tool. There are so many parameters we can pass to that function. Don't be happy with only what is its task and then taking the code and then trying to pass the parameters. So please see what are the additional parameters it accepts and what is going to happen. And if you are able to implement such a generic function, it is wonderful. You know how complex it is, right? How do I, because it is again, you can enjoy your programming language concepts also. It is a function with variable number of parameters. Do you agree with me or not? Yes or no? It is a polymorphic method. When it comes to a programming language, it is nothing but a polymorphic. So means, if at all you are going to be an experienced or a developer, probably you can link to your programming knowledge also, wherein which those functions could be simulated with various what are called as the parameters, and also should take care of errors. The program should not terminate abruptly, right? So that is what is expected. Program is supposed to run continuously or generating a warning message to the user. That is what is expected. And that is where the exception handling comes, right? So can you build any algorithm which also includes exception? Means when you are trying to implement a convolution operation, when you are trying to implement a loss function, see that it contains set of specifications on par with the generic APIs that are already available in this public library. Okay, that's what. Because that enhances your implementation capability. And one such we tend to use more often in the care. So it's high level neural network APIs. When I say neural network APIs, whatever the functions that I mentioned, the layers, convolution layer, flattening, max pooling, right? Optimizer like Adam or say stochastic gradient, asymptotic. So many are all part of this particular library. Okay. So initially you can just explore what are called as the library that are available, and later on trying to design whether the output matches with the output that are available there. Okay. On the other hand, PyTorch, as you know, it is GPU, and nowadays people basically looking for that GPU-enabled system because the large amount of data to be processed. Because of the GPU, we could realize the applications which I hope to show you at the later stage. And definitely with conventional machines, it is not at all possible. And a laptop, I can give a demo for only 16 to 100 images, not more than that. And if I submit large amount of data, probably that goes in a dead state. It's not at all possible. But you need to experience with firstly small amount of data and later on trying to deploy it onto this. And there are what are called the options available and facilities or some kind of what is called as the environment is provided by the government to access to the such resources, high-end resources, which are available in general institutes of national importance. I mean, definitely a university or an engineering college may not afford to have a GPU system, NVIDIA processor with high-end computational megaflops operations, which cost you 1 crore or 2 crore, something like that. Definitely it is not possible. So therefore, Government of India has a scheme wherein which a researcher can access the resources that are available in institutes of like IIT, IIS. They have the systems. Only thing is you may need to write to, there was call for such what are called as the facilities, then you need to apply and definitely can explore going there and then using their systems and solve your problems. Because that is one of the limitations generally teachers we used to face, so computational resources. So how do I get a paper which is similar to AlexNet? Definitely it is not possible with the limited resources what we are having. It is true with respect to the university system also. Even 32 GB RAM with high-end 2 lakhs investment, a workstation also, may not be able to solve the problem because they work. Can you just imagine the amount of data that tend to be processed is in terms of GB. So maybe or in terms of TB. 1 TB of data of let's say 1 day video, surveillance videos. Then they process it for 7 to 10 days. And that's what AlexNet people say. They run on a GPU. So parallelly, okay, for about a 7 week to get a result, to get the predefined weights, and subsequently they won the competition, and that is a story of course for us, but for them it is the reality. Okay. But still, you can explore those, maybe talking to the institutes. Okay. So types of deep learning architecture. So maybe based on CNN, also autoencoders, long short and GANs. Several others are also there, as you can see. I mean, these are the trends that are tend to be. This is again increasing order, as you can see. So people invent newer and newer architectures. Okay. So earlier it is again even nowadays also when it comes to image processing. So convolutional neural networks based models are very powerful. So RNN and variant of that is LSTM, very powerful for one-dimensional data representation. Autoencoders, so they are a kind of what is called as the, it is similar to a principal component analysis technique. So generative adversarial networks, again additional data, fake data is generated, and that is an advantage. Data augmentation and then learning is too possible. Of course, transformers, capsule networks, spatial transformers, also there. I'm not gone through these details, but still this is the literature so far available on 20, 21, 22. So which you can think of implying to the problem that you are going to solve. Okay. So let me just focus on to image and the convolutional neural networks more because that is important for us And probably for biometric data processing, it is the convolution neural networks that playing a significant role, which provides me what is called as the computer vision, which you are already familiar or known, right? Giving the computers the ability, what happened? Giving the computers the ability to understand visual information. So that is what is called as, in a broader sense, which you already familiar. See here, the robots can move around obstacles. And in Mysore also, there is a robot installed in Sandesh Hotel, the Prince. I read in a newspaper. And it is there still. Siddhartha Hotel, Sandesh. So it serves our purpose. Maybe they attracting the one way of attracting the customers. Definitely, children are very fascinating to see. Even if you are not interested, your younger brother, sister would be more interested, keen on seeing such robot. Again, it is a market trend for them, business for them. Yeah. Whatever. Okay. So how it is going to be? It is again analyzing the image data. It is finding the image scats in millions. This could be the problem. I will show you a simple example over here. When I say it is an image, so as a computer science or a computer vision expert, scientist, you would say from picture you are going pixels, right? So this is the image that I am having. So that image is mapped to what is called as a matrices. I call it as a 2D tensor. And from picture to a pixel and from pixel to understanding. That's all they are doing in learning of computer vision. See how beautifully they mapped. So it is the image data that gets analyzed and subsequently I am able to understand what is happening around. Okay, that's all the computer vision. And it is very simple for us, as you can see here. So this is easy for the humans, but for AI it is actually one of the harder problems. What do you mean by that saying? It is understanding. What do you mean by what do you understood by this? So what do you understood? Suppose given a picture something like this, you would say there is a cat among some flowers, right? In the grass. That's what we say. Can I generate that description given an image data? It is again a research problem. Take the image and can you annotate the image? People are working on that, image annotation problems. Okay. So how do I generate such information? It's all the way that you capture it, train the system. It is too possible. Okay, it involves analysis of the image and also natural language processing, text generation that depends upon the data that you are having. See here, effectively what we are doing, we are transforming the grid of numbers into understanding. This is simply set of instance values, normalized of course, as you can see here. Okay, to overcome the effect of elimination, I do the normalization. And then when this data is given, nobody can say anything about that. But system is able to, because system can understand numerical information and subsequently I can produce the results. Okay. And this is what the role of course in AI. Okay. Similarly, of course, this taken from some other. The building picture somewhere else is eliminated over here. We can easily say it is a picture of some building, so on this glass. But for the AI, can it done? So it's really difficult if at all I want to achieve. I mean, people working in the field of artificial intelligence take sometimes nonsense problems, but later on they may be useful to the society to solve some problems which are helpful. Research is something like that. You take something problem which is unsolvable and can I solve through the computer vision? Very interesting. That's where, of course, your research also. Identifying the problem itself is a complex problem. Okay. And once you are done, then the next stage is go for solution. But can the problem be solvable is again another question. Therefore, when you are starting your research or you are aiming to get a PhD, don't invent the problem which is very complex. Suppose if somebody is here trying to carry out a PhD, don't invent a problem which is very complex. Try to take a problem which is well defined, solvable within a period of 3 to 4 years, so that you will get a PhD, right? And subsequently can develop, grow on your own. Most important. Okay. That's what. So I used to say to all of my students also, what the experience. Okay, take the problem which is well defined because that reduces your burden, I will tell you. Okay, otherwise taking a very complex problem and then struggling at some point of time you become frustrated. So researchally frustration will work. So you should feel every day and try to, yes, I'm going to solve this problem. Let me just sit and work maybe hours together, prepare with the slides and presentation, things like the presentation. So today I'm coming for the presentation. Last all through week I sat and then take the data from different places so that people should understand. Because we cannot give, as I told you, in a span of an hour or so. It is just a transformation, in a way it is a transformation function. So take some input, not all input need to be processed. That's all. So when I say it is again convolutional neural networks, it is again either fully connected, because these are the terminologies that are being used. So or it could be fully connected or densely connected, or maybe minimal connection would be there, as you can see. So how do I get a minimal connection? The minimal connection could be obtained through what are called as the dropouts. So means reduces the complexity to some extent. Some connections are not required, then eliminate those connections. That's what we are trying to say. But how do I eliminate such connection? So there is a theory behind that. Okay, how do I, you cannot randomly or randomly eliminate the connection. Maybe those who are not contributing can be eliminated. That's what it is. Like Ronaldo has kept out of the game, right? They thought we may not do this, but they failed. So some more explanation on the, as you can see, on convolutional, given a 3x3 image data. Okay, so you have the filter and then you keep executing that. As you can see, this is a pictorial view. Of course, this is it, right? See the amount of effort that the particular original researcher or presenter has. We are using this slide. So creating slides with creativity is also interesting, so that you can understand. More important, because it is my experience also. When I started my research career, I do not understand physically what is going to happen when somebody says, take the classifier SVM and then with all kernel functions, things like that, then they are saying, it is out of the head. Then we simply kept quiet, close our eyes, literally. I mean to say that keeping your brain seeing through the lectures, but not, so let him say anything and let's see at the later stage. That's what. It happens. So as a beginner, probably some beginners are here, it's quite natural that we may not understand simply the bits and bytes. For a researcher, so those things are very much necessary. Please understand the fundamentals and later on you can build it. It's really easy. Okay? And you can enjoy ultimately. So what is going to happen when I do the real example that just is given? And please note the kernel also, kernel orientation. See, kernel orientation is on the left and the other side is the right. So what does it give me? As you can see here, edges inclined with this direction and edges inclined in the other direction it will provide. I mean, simple example to illustrate what do you mean by a convolution and what is meant by a convolution kernel and what is its effect on the data. That's what we are trying to see. I mean, is there, when I am trying to say that it is a building, probably this knowledge would help for the system to say it is a building because it has a specific structure. But how to link all those is again an interesting issue. But for the time being, just try to implement this. That's all we need. Okay. So ಮತ್ತೆ ಸಿಗುತ್ತೆ ನಿಮಗೆ ಮೆಟೀರಿಯಲ್ ಎಲ್ಲರ ಒಂದು ಕಡೆ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಿ ಸ್ಲೈಡ್ ನೋಟ್ ಆನ್ ದ ಸೇಮ್ ಆಫ್ ಕೋರ್ಸ್ ಯು ಆರ್ ಗಿವನ್ ಎನಫ್ ಇನ್ಫಾರ್ಮೇಷನ್. So let me visualize it as far as the convolution is concerned. When I do the image data, so why I go for, let's say for example, more number of layers. See here it extracts the primitives and these primitives forms what are called as the objects and subsequently I should decide that is the I mean, I'm looking for these kind of features in the image data so that I can decide that this is a. These are the primitives which could be extracted from a kernel of different types, and subsequently they integrated at the next level, and then I'm able to interpret. Okay. So visually, I can give you one more example. See here, as you can see here, learn low-level features through convolution kernel. I mean, edges structure in a given image. Then little higher level, next level of abstraction that I could see here. Then higher level of abstraction, approximate figure you can note out from this. And this is the data that I am going to use to say to the cat. So more the number of layers, better is, but not always. Please note. Okay. And as far as any architecture is concerned, it is all the number of layers that are adding along with the size of the kernel. Okay. That's why I told you to implement this. So generally when I say it is a color image data, you are also going to augment with the data augmentation. So with data augmentation is another, of course, novel contribution by that researcher during that time. What they did, when the data is not available, then it results with, say, a regularization problem. Then in such cases, they go with adding the additional data. How do I add the additional data? Take the scale version of the same, rotated version of the same, set that to generate an additional data. Data augmentation results with improved accuracy in many of the cases. And people have published in a reputed journal. That's what the benefit. I mean, out of the box thinking. When it comes to research, how do I go beyond? So rather than a conventional, that's what we need. So if the data set is small, then we generally go for what is called as the. So if I hold continuously, it goes to the off state. That's what I learned. Okay. So shifting, rotation, cropping, scaling, adding mass, etc. All those things are possible. Okay. So more, as you can see here, there is a function available, what is called as convol 2D. So please note down, look at the corresponding parameters also when you are taking this function from existing API and trying to simulate the same. So through either C++ or OpenCV functions, you try to do that, or in Python long, doesn't matter to me. Okay. And the other end, pooling, of course, it is quite simple. Max pooling concept that we have taken over here. When I say it is a pooling, max pooling, as you can see here, it is an image of size 4 by 4, reduced to 2 by 2. Take the maximum in the data, divide the image into a set of sub-images, and take the maximum in this list, maximum in this list, maximum. So it gives me this out. And why we go for this, I told you in the beginning the example of the dog, right? Even though you eliminate some unwanted data, doesn't matter. It still looks like that particular image only. That's what this max operator is. And since you reduce the size, obviously you are going to computationally make the algorithm more efficient. Okay. That's what when I say it is a pooling layer is. Okay. Max, sometimes people also take average. Okay. So it's just take the average of the data. That's also possible. But generally it is a max pool function and see what is going to be optimal. So use this function and also develop your own function and see what it is. Okay. So similarly there are other layers. So flat to dropout, similar with dense layers as I told you. Okay. And the function that are available. So when I say it is a flatten, converts input into a vector form. Okay. So how do I convert input into a vector form? It is a keyword row concatenation or a column concatenation, which is very well known to you. Overall, when I say any architecture, what we are seeing in the days to come, so they basically contains, okay, the given input data, right? And this input data is submitted to what are called as the convolutional kernels, the activation functions, and then the max pooling or the orange pooling. And this gets, of course, one or more fully connected layers. As you can see, repeat one or more times. Any architecture that exists today will have these basic components. And finally, a fully connected layer followed by software version. typically, when I say it is a convolutional neural networks based architecture, so they use judiciously the combination of these different what are called as these modules to come out with what are called as different applications. Okay, let me just go to that different architectures based on the convolution kernel. Okay, what are those? One is the AlexNet. Okay, so which is very well known, and as I told you, it is the first deep learning architecture, and that is by the author only. The particular architecture is taken in the corresponding paper, and I want to probably I will share a copy with you, Bharti, the paper, okay, so that they can refer to it. For the sake of completeness, let me show you. So, ImageNet classification of deep neural networks, as you can see here. See, they explained all those. And just for your information, they use the GPUs, intra-GPU and inter-GPU connection. But almost they took see, the training took 5 to 6 days on 2 NVIDIA GTX 580 3GB GPUs. So the cost is definitely more than close at 1.5 crores if I go for such architecture. So means to say the amount of data that they are going to process is also in terms of millions. I don't want you to touch upon or work on such complex data in the beginning. Please take a very simple data set. Standard simple data sets are also available. So please take some simple data sets and trying to run AlexNet on that, and let's see what is going to happen. Whether it classifies cases or not, you can just try it. Okay. So this I can share with you, and along with that, it's published in an ACM journal, ImageNet classification of deep convolutional neural networks. So this is an interesting paper, contain the details of the AlexNet. And when you go through this architecture, they say here the kind of what are called as the activation function, and they say here the normalization, and they say here the kind of loss function, and also the kind of tuning. Along with of course, see here, you can see here kernel 11 by 11 size. Okay, so with stripe, and then a 4, then gives me what is called as 55 by 55 size data. Again, do the max pooling, and you know what is meant by max pooling. Again, a convolution operation, do the max pooling, then dense followed by the fully connected load. So it is a combination of all those basic components. That's why I told you in the beginning, please be familiarize yourself before you leave probably at the end of 4th or 5th day. So familiarize yourself with these basic models. That gives you an insight into solve different problems. Different problems would be not necessarily biometric, as I told you. It could be anything related to computation. Somebody is working on object recognition, segmentation problem. Okay, so you can just even classification of the diseases, COVID-19. So people now working on that. So digital pathology, different kinds of image data that are available, and deep learning are extensively explored on this. So this article is cited, as I told you, more than 100 times. It's a wonderful article. Please go through this, where they are given that they are successful in identifying or achieving the best accuracy as far as ImageNet computation is concerned. And every year, for your information, either CVPR, Computer Vision and Pattern Recognition Conference, top Tier 1 conference, having higher achievements, of course, okay, impact factor conference. And similarly, ICPR, International Conference. There are more than 30,000 papers that they would receive. Out of that, acceptance rate would be 10%. And very, very interesting research articles, state-of-the-art research articles you will get, referring to such. And apart from the paper, they also give you the code, they also give you the presentation. So 1 month generally is kept open so that you continuously refer to such websites which will help you to understand the newer works. But for that, you should understand the basics. Otherwise, it is very, very difficult to understand their thoughts because you have to have the background knowledge. And for that background knowledge is this what exactly is. Okay. So similarly, as you can see here, the VGG net. So I don't want to touch upon again internet. There is nothing more to explain over there. It's just convolution question, max being operation. And what corresponding functions that are available, if the time permits, probably I will just go through. Similarly, the VGG net, as you can see here. Okay. This is again Andrew Zimmerman group. He is one of the excellent teachers. At University of he is working in University of Oxford. Okay, and they have what is called as visual geometry group. So he is the one who was given. I attended one of the conferences, top AAA conference, artificial intelligence. Okay, so Asian conference on artificial intelligence. He has given a lecture on Google video during those days, 2006. So I used to say that input the video or an image, it will give you the list of all the videos and also the images. What is now realized today, and he has dreamt almost 15-20 years back. So excellent researcher. Please go to his website, and they are given a code, paper, everything. So that is, we are sometimes hesitate to share our code and all. They are not at all bothered. Just take this because that's the idea behind open access, right? So that your article gets more visibility. Okay, and of course, institutes supposed to protect support financially. Very rarely we get universities, engineering management support us in terms of makes your article open access. So that open access also has limitations, but IEEE access, as you know, probably what is given to you is open access journal. So please refer to such state-of-the-art works. But some are not good, even though it is an IEEE, but still some quality is maintained to some extent, but not that much good when it comes to a family. So family, as you know, ethical transaction, patterns and machine intelligence having the impact factor 26 or 27 or so. It's one of the excellent journals, and I want you to read such journals because the way they presented the concepts is just cannot. I mean, you are going to enjoy it. It is like a beautiful recipe. So you can enjoy the food when you put a good recipe like that. The journal articles are like that. You take the articles which gives you result day after tomorrow. Submit today and day after tomorrow. They give something which you cannot enjoy reading such. So I don't want you to read. Publish one article which is good enough for you to and gets citations, most important. Similarly, ResNet and similarly large scale freenet, pre-trained weights that I mentioned, no transfer learning. I stop at this stage. I mean to say that not my lecture, they usually stop at this stage. Don't build the fully connected layer, and then they take that are the weights which are input to your newer problem. Okay, so that's what when I say the transfer learning approach. So several, of course, models here we have combined several models trying to ImageNet. These are the various network architectures that are already available. Only thing is a matter of exploring. And a simple problem, let's say for example, if I cut the network at this stage and call a fuzzy genetic algorithm or a fuzzy SVM for some class, it may be a contribution from your end. You do not know. It may give a better result rather than a softmax classifier. I can build my own classifier that works better, which we do not know. But only thing it is by experimentation, based on the data, based on the features, based on the number of layers that you are having with respect to, and you can build your own what is called a deep neural network. Not necessarily you can think of using the same structure. You can build your own neural networks. Have dense, have the max pooling, similarly have the convolution layers. Randomly you just think, see what is going to happen for some particular problem. If it gives a better result, then be happy with that. That's all. But whenever you are considering different convolution layers, different filters of different size with different pooling and dense connectivity, etc., they should have some intuition behind that. I mean, you are supposed to look at the internal structure of the image and its behavior so that you can judiciously decide whether it is suitable or not suitable. Similarly, that's the top. So there are of course a lot of applications we can find, and one such is very interesting. What is that you observed here? I mean, in all these videos, they are different videos. Irrespective of the complexity in the environment, it is able to localize the object, what the object it is. So, YOLO is the one that is being used extensively in the literature for locating the objects. And then, based on that, you can take, suppose I can build an autonomous vehicle, driverless vehicles, people tend to say, and it sits on the backbone. And this sits on the network architecture. It's again the backbone for that. And the network architecture sits on Keras APIs. And again it sits on the lower level CWS concepts. So interesting. Therefore, so when you look at the problem at abstract level, go into the details so that you can really enjoy. And similarly, one more on the same line. Let's see here, as you can see. Real-time semantic segmentation. As you can read through, each frame in the video is processed 30 frames per second. So that is the power. Automatically it does the semantic segmentation, as you can see here. People will ask, what is the benefit that you are having? So, segmentation is a complex process, as you know very well. Image segmentation is a complex process. It is able to correctly segment out. This is what the kind of problem that are being addressed by the computer vision research community in reality. Taking the real world problem, if I say. It's quite interesting to see the video lectures, and this is the kind of paper that gets accepted in such top tier conferences. And try to aim it, try to look at such kind of, and data sets they provide you, okay, and basic code they provide you. It's a matter of your interest and learning. And the only thing is the computational resources. I know it is one of the major problems, okay, particularly when you are working in state universities or the institutes here. Probably that's one of the limitations, but you may need to figure out that. So similarly, I'm just telling you the different examples which I explored. Cannot build a graph structure which automatically based on action. And action recognition is, as you know very well, for various problems. Opaque, verification, those kind of things. This is three parts and color coding value. Different problems. We analyze the video and then trying to say where it is useful. Similarly, one more I just wanted to be, because this is my interest. So what is the power of face recognition? This is released by this as you can see here. And recognizes recognition. IJA is the data set that they are using. And a lot of problems have been solved. real-time facial recognition. Irrespective of the face pose, they are able to recognize. It may be in the mall, as you can see here, automatically your face gets detected. I mean, this is what the kind of problem people are working on, and we are supposed to understand the data. And the system takes minimum 2 to 3 years over the development time. But this again on the back end is the researchers contribution. Irrespective of the variation in the pose and lighting condition, occlusion, is your mask right, but still it is able to recognize. You are developing an algorithm which says yes, it is a invariant to mask kind of problem, any problem. All those things as you can see here, 30,000 and it can be enhanced also, exploring the deep learning model. If you join, let's say, Panasonic company, you can think of proposing your own solutions. Only based on the face search, people tend to work on that. So like that you can find a number of applications which explore different deep learning architecture to solve real life problems. When I say it is a biometric, I think now I come to the actual domain, but still we can link whatever, because I say forget about biometric, it is simply an image data, that's all, nothing more than that. Different modalities are there. The combinations could be explored. Okay. And if you look at the timeline of, let's say for example, this is with respect to the conventional classifiers and this is with respect to the deep learning models. The same phase analyzed at various levels with different architecture, as you can see. Okay. So convolution layer, pooling, max pooling, and it interprets the image at various levels and trying to able to locate or detect the faces. If I am say about the face, similarly with the IDs, with respect to the fingerprint and so on. And a combination of those would be used, I'm sure. And you already listened to a lecture and you are going to listen a lecture on internal details of those. And if I look at the timeline, so here, with respect to the face recognition is concerned, so conventional holistic approaches to the edge-based approaches, PCA, and now it is the era of deep learning. And you know who is? Who this person is? Up at the end it is there. Well-known football player, irrespective of the pose. Huh?
Messi.
Okay. It's there anyway, even otherwise. At the end, whether it's classified correctly or not, irrespective of the pose or interesting. And people take such videos. Can I just track where Messi moved in a particular game? So it is a question for you. So can you do that? Because videos are available. Just see whether you can track the movements of it. So that people will learn the football player. Let's say I would like to become Messi in the future days. Not Messi, not Messi. It is Lionel Messi. Okay. Then you are going to be Messi. That should not be. How do I achieve that? See, plenty of algorithms are available. So if I just take from 2012 onwards, so 1920, you can see plenty of algorithms that explore deep learning. And it is a matter of, as you can see in all these, it is a matter of only changes in the loss function, changes in the architecture, changes in the number of networks, and the corresponding training set. The training set is, of course, is very large. Okay, Cassia, Facebook. As you can see, there is 4.4 million. Okay. So that is the number of images that they processed like that. Similarly, celebrity faces. So Cassia is one such which is not only for the faces, even for eyes. We provide Chinese Academy of Science. Wonderful, very good research laboratory. So works on different modalities, biometric modalities. Very interesting. Okay. So as you can see here, different deep learning models, deep face, deep ID, and so on and so forth. So variants of these are available, and the variations is where variations in only in the usage of the loss functions, as you can see here, softmax, or as you can see here, central loss, LSoft, range loss, L2, and so on. Similarly, the architecture, as you can see here, Alex, VGG, and so on, ResNet, different architectures have been explored. Okay, and the number of networks that they are used. It is changes in such parameters over time. So it gives you, I mean, probably if you are interested, you can just go through. I can give you the survey paper or some Bharti. So please go through. And all these, the basic component is what? As I told you, that's why in the beginning I said, if you look at the anatomy of what is called the deep learning framework, it consists of the layers, it consists of the functions, class functions, regulators, and then pooling. So those things, and optimizers. So any network, if at all I consider here, it's only those changes you are supposed to see. Not only for face recognition, you can also see for fingerprint. Again, a sequence of convolution operations are built over here to extract the minutiae points, interesting points over there. Okay. So I'm not going to give the details here. It's just matter of if you read through that particular paper, it comes to know that. As you can see, giant conference. IJCB is one of the excellent conference, highly indexed, well-known conference in the domain of biometrics. Suppose if at all your interest is into publication in the biometrics, so please look at IJCB. So it will held sometimes also in India. So generally outside. In 2015, I think it was in India, IIT Delhi. So very interesting research articles. I want you to attend a conference which are sponsored by IAP. Generally they are good. So International Association of Pattern Recognition. Okay. So please attend to such conferences. They are basically good, means to say they have invited good lectures. Okay. Good workshop they organize. So a lot of material and good number of researchers are there, most important. So they are freely available for discussions most of the time. So apart from meeting, chatting is all there. Conference is not just, suppose you come here, not only this, in the evenings you can enjoy. You can go for a coffee, meet friends, move around. Because you should physically get to know all those things also, because that gives you a different mindset. Come out from conventional environment. That's what the conference is for. When I invite some people to India, they say, no, we are not here to come and sit and work with you. We just see India and all cities that are around India here, and then let me go back and then discuss with you these things. That's what people say. And we tend to do that also. When you go outside, hey, don't sit and work on the system. Please see our country, culture, everything, and go back. Work there. That's your place to work. Similarly, palm print, you know very well, which is one of the another biometrics. And see here, it is all playing around those basic models, nothing more than that. It's a legitimate combination of integration of different models to extract images and subsequently. And now and all, there is nothing like a rule that is available. ಯಾವ combination evaluable. It's all intuition, and maybe analysis to be done in order to come out with a solution in the problem. Even for gate recognition, it is published in 2016, of course, based on the Siamese networks. So like that you can find different what are called works based on biometrics. And when I say it is a multimodal, you can definitely imagine, right? Combination of two or more modalities having, let's say for example, different deep learning. Let's say I use AlexNet for both face and also a fingerprint, and then do the combination. And how do I combine? Probably next session we will be dealing with that. How do I combine different modalities so that I can come up with it? There are various ways. Several researchers already done the invention. So we are going to combine, there is standard ways of combining the multiple modalities, either at sensor level or at feature level or at decision level. So many ways are there, and I think Sharmala is going to discuss in the afternoon. With this, I will conclude my talk. 12:30, is it okay? Because, huh?
Some discussion session.
Yeah, therefore I would say generally image processing is very, very complex. I'm sure you know this. If I ask you how many tigers are there, what is your answer?
4,
You might have seen this in the Google also.
5, 6, 7, 7, 8, 300.
It depends on how well you are trained your brain, your mind, to see things which is unknown here. Seeing the unknown. Seeing the unknown. So, solution is there.
19, 10.
Not a estimate.
Oh my god.
If you do Google, you will get this. It is not. It's just not only the real, it's also take the fake images. But can I identify such fake? Is the question. And that you have to think with the help of different deep learning models. So that's all I would like to talk about today. So I just wanted to put one quote. It's all the knowledge that we are having is only in our brain. Only thing is you have to realize. Ultimately to say, human brain is more powerful than any other computer vision system or artificial. Nothing can beat human vision system. The best example is, of course, let's say I ask you, who wrote? So let's say I am not trained on the font, but still our system is able to see it, right? It is Swami. If you know the code, it's fine. Otherwise, through different epoch style, still we are able to see that. Okay. So that is the power of human brain. Somehow we have the habit of inferring the knowledge from the existing. That's the ultimate, of course, and exactly what is required. And how do you do that? Deploy, like the machines to think, machines with mind. That's what I told you in the beginning. When I said it is an artificial intelligence, it is nothing but machines with minds. How do I do that? It is really very, very complex. With this, thank you very much. Now, any questions? Otherwise, anyway, we will meet during tea time and also I will be here in the afternoon session. We will see. Okay. And this is the first session, so I know the complexity also. Some are teachers. Anyway.
Regarding to my personal PhD work. So I have a biometric BP, something like evaluator, which is an IoT connected device. So from that, since I am working on sleep recognition system, in which eye features were collected on online through camera and even through by video. So will it be possible that an IoT device connected to this biometric system?
It's only a sensor, right?
Yeah.
I would definitely can be connected to an IoT. It's a matter of sensor data. The sensor is your camera that is subjected to connected to your.
Along with I want to combine with my BP value of a.
Yeah, that's all.
For
It is
sleeping.
all the data analytics problem. One is the image data, another is the signal, BP signal data. And using those two modalities, you can design what are the features that says he or she is sleeping or not. It's a simple two-class problem. Definitely it can be solved. Absolutely. And again, the issue is what data that you are going to collect. How do you collect the data?
Digital format.
So what you can do is rather than integrating initially with IoT device, you first come out with a model that works with videos of sleep and also the signals, okay, and the heart rate, what are deep levels. Then trying to build the IoT system. It's a matter of plugging in the components at the latest stage. Should be definitely solved.
Could you suggest any specific model that is almost near to the solution?
It's a very, very simple problem to my knowledge because it's a matter of analyzing whether, let's say for example, you take large amount of data, take the different people's what is called as the BP and see what should be the threshold to be set to say he or she is sleeping. Similarly for the eyes are supposed to be closed, no? So it is the only solution for that. Therefore, it's very simple. How to verify the eyes are closed.
So before we get sleep, that can be seen on the eyelids.
Okay.
This is the BP that gives us
Okay. So
in-
I can see somebody sleeping also when you are teaching
Yeah,
now. So like that, of course, it should be continuously
monitored.
captured. The frames are supposed to be captured. Take the successive difference among the frames. At some point of time, it gives you simple what is called as the I would say kernel difference between the successive frames will give you the solution. At some point of time, you'll have what is called as a spike. That is, it's a kind of what we call it as a kind of wipe operation as far as short boundary detection problems are concerned. So there are abrupt shot as well as the slowly it gets converged. Slowly child gets into sleep. So as a mother, one could able to make out at what point of time. So it's a matter of observing the video and take the correct. So just wipe, you take the algorithm that are already available in short boundary detection as far as the wipe detection are concerned. That can be delivered deployed to your Yes. It's a simple transfer learning. Yes.
Yeah, Professor, so my name is Rizal from MIT. Regarding the facial expression recognitions, I've seen most of the algorithms or most of the models have used deep learning based, like the models, most of them. And what do you think, or like in your idea, the best approach for or the best model, which is based on deep learning? For,
No, it basically
compound-
depends upon the data.
Yeah.
So the one which works for some class of data may not work for other class of data. And randomly we cannot decide, yes, this is the
Okay.
best model, it works for.
No, I mean like
So
throughout.
probably for that, what you can do is we can refer to the works on fine grain action
No,
recognition.
my question is not finished. The question was on compound facial expressions.
Yeah, that's what. So when you look at the fine grain action recognition problem, it would, I'm sure, a solution to your issues. Facial expression recognition, so is addressed because one would simply, suppose you take the example of smiling.
Yeah.
So it's one would smile in various ways, but is it possible that your system is able to identify? So means just simple details, very minute level details. Can I observe it so that I can obtain a solution to your problem? And the problem is referred as in the domain of object recognition, fine grain action recognition, in the domain of action. And this facial expression recognition is a subset of that. Several models that are available. You just see that and explore one possible solution. Okay. And on spot again, which VGG Alex, I cannot say because it is to be explored.
Just wanted to have your idea because you have been.
Okay, no issues. You experiment with AlexNet or build your own net. Don't depend on Alex. Build your own net and see whether it is able to recognize the expressions. So limit to first, say for example, 3 expressions. So angry, sad or smiling. And later on you extend it and take the data. You capture the data, your own data. It's also possible. And see whether it works or not. Because our smiling would be different from foreigners' smiling. They do sometimes very sarcastic smile, right? If at all I am not good, they give a smiling in different way. That beyond that is anyway, in general you can work with different data sets, but only thing is when you are use the existing models, it is by experimentation only that you need to realize. And that is number 1. Number 2, generally for your problem, to my knowledge, RESTnet should work because it is a residual network. So just experiment with RESTnet with what is called transfer learning. So maybe you can.
Single facial expression,
It
you
should work.
but when it comes to compound,
Mhm.
like if, for example, somebody is surprisingly happy,
Okay.
like that makes it a little bit.
I think RESTnet should work looking at the characteristics of that particular model. You just see, okay? And go through first how it functions, and later on we can build the details of that first we need to plan. Okay, before implementing completely on a whole data set, take simple expression, one image to image, and check whether it classifies correctly. Okay. Right.
Sir, I have, can you throw light on like how to modify the parameters or what are the adaptive factors that is there in all these deep architectures so that to suit a specific
I will give a very simple example for that. So when I'm working on a face recognition problem, okay, kernel PCA is probably some of you may have read, okay, and having varying sigma will have an effect on the face recognition. It's again what is called as hyperparameter. It's supposed to be submitted as an input to the system. So sigma giving, say for example 0.1, the accuracy will be 30%, 0.2 the accuracy will be 70%, 0.3 the accuracy 90%. So generally when they release the code, no researcher will say what should be the parameters to be set in order to get the good results. It is by again experimentation. Okay. With repeated experimentation, and while setting the parameters, so normally what is the best set of parameters to be considered? For that there is one technique called grid search. So which gives me optimal set of parameters for a particular class. You can explore it. So Buesh has worked on that, on microarray data classification, grid search approach for hyperparameters.